Fusarium venenatum, a novel complete protein source and sustainable meat alternative. Author Ariel Rupše. Introduction. Increasing global greenhouse gas emissions from industries such as animal agriculture result in severe environmental consequences. Hence, it has been deduced that global emissions from livestock must drop by 61% until 2036 to align with the goals of the Paris Agreement. This study investigates the effect of varying concentrations of protein-rich industrial byproduct additives such as okara, soybean residue, and bone meal in growth substrates on the nutritional composition of Fusarium venenatum, focusing on its amino acid profile, protein quality, and antioxidant compound content. The aim is to evaluate the potential of this fungus as a complete and sustainable protein source in comparison to other protein sources and potential as a functional food ingredient for plant-based diets. Experimental part. Firstly, substrate preparation, followed by solid-state fermentation, soluble mycoprotein analysis, phenol analysis, and amino acid analysis using high-performance liquid chromatography. Results. Substrate coverage by Fusarium venenatum mycelium in various samples was compared. The values range from 35 to 95% coverage. The results of these calculations suggest that both additives affected the growth of Fusarium venenatum. The grown mycelium is shown in Figure 3. Soluble protein analysis showed that okara 10% and the control samples had a higher soluble protein content, and phenol analysis showed that okara 10% samples contained 67.2% more phenols than the control, increasing antioxidant potential. Okara 10% samples significantly increased essential amino acids by up to 150% and non-essential amino acids by up to 45%. Bone meal 10% samples had a smaller overall impact compared to okara 10% samples. Compared to other protein sources, okara 10% sample obtained a higher value of protein content than lentils and chickpeas and was close to the protein content of eggs. Additionally, Fusarium venenatum grown on okara was estimated to have the lowest carbon footprint of all products. Conclusions. For achievement of environmental sustainability and a better nutritional value of Fusarium venenatum mycelium, substrate was modified by adding okara and bone meal at 5 and 10% concentrations. Okara 10% sample showed better results than bone meal in terms of protein and phenol content, obtaining 9.48 grams per 100 grams of total amino acid mass and 50.5 milligrams per 100 grams of phenol compounds. Okara mycoprotein had a higher protein content than lentils chickpeas, nearly matching eggs with the lowest carbon footprint among all examples. Therefore, food waste can be effectively used for alternative protein source production, with okara proving to be a superior additive for improving both protein quality and antioxidant properties.